Okay, so we're looking at number 1, and we're doing it again, just like we were yesterday, giving an algebraic pattern for a table that has a box number and the given number of circles in that particular box. So we know we have to show work for these, so how could we start the work underneath this one right here? How do we show the work underneath that one? Sylvia?
1 plus
1 + 1 = 2. In other words, what do you have to do to the box number to get the number of circles? Okay, and does that keep working? What do you have to do to the box number to get the total number of circles? 2 + 1. So in other words, what are we doing every time? Adding 1. So let's just make sure, let's prove that it works all the way across, that every time we get a true statement, so did we get a true statement all the way across? Yes. Okay, so which algebraic pattern are we going to circle? C. What does C stand for in the algebraic pattern? The number of circles. What does N stand for? The box number. So it says to get the number of circles, you take the box number and you add 1 to it. Okay. Check out the next one. Figure that one out. This is stuff we had to practice yesterday, so I'll let you try and do these as much as you can on your own. Pattern this time. What are we doing? Wait.
N minus 3 equals C.
So subtracting 3. So from the box number. Okay. So
No, adding 3.
adding 3. Okay. So if we add to the box number 3, we get the total number of circles. Well, it looks like it works for the first one. That does work for the second. Works for the third box. Works for the fourth box. And it works for the fifth box. So what's our algebraic pattern?
C equals N plus 3.
C equals N plus 3. Okay, I'm going to challenge you to do one more thing with this problem though. I want you to find, so write this first. Find number of circles in box 25. Show your work. Find the number of circles in box 25. What'd you get, Paikia? 28 circles in box 25. Anybody else? That answer? Okay, Cheyenne did. Wade did. Harley did. Sylvia? Okay. 28 circles in box 25. Anybody else have a different answer they want to challenge with? Okay, tell me how to do the work for this one. How do you do the work for this one? Cheyenne?
25 plus 3.
Okay, so we have to do C equals 25 plus 3. Take the box number and add 3. So C equals 28. So we say 28 circles in box 25. Okay. So just a little add-on. number 3. What do we have to do to the box number to get the number of circles? What do we have to do to the box number to get the number of circles? Katie,
Take a minus 1.
subtract 1. Okay, let's try it. Box number 1, take away 1 gives us 0 circles. Looks like it works. Box number 2, take away 1 gives us 1 circle. Looks like it works. 3, box number, take away 1, our pattern gives us 2 circles. Looks like it works. 4, take away 1, should give us 3 circles. It does. 5, take away 1, should give us 4 circles, and it does. Okay? So what's our algebraic pattern? Which one? Letter A, B, or C? Letter A. Okay. Okay, without showing work, tell me, how many circles would be in box 98? Danny? 97. How many circles would be in box 7? Class?
6.
6. Yeah, we just have to take 1 away from the box number, don't we? Okay. Anybody got questions? Okay, let's go to this next page, at the back side of that page, or is it on the next sheet? I don't know which way it is, but we're doing activity 1, where it says use a variable to write a pattern for the following 100 square grid numbers. Okay, our algebraic pattern is going to have just one variable in it. It's not going to be an equation. We're going to write what we call an algebraic expression. So the first thing I want us to do is I want us to make this little note up here to the side. N is going to be our variable. So N is the shaded number. It's going to represent any shaded number in that table, in that 100 square grid. So you need to write that. N is the shaded number, because that's how we're going to describe our pattern, is what do we have to do to N to get the next shaded number. So see if you can figure out the pattern. What's going on when you go from one shaded number to the next in a 100 square grid? Or in other words, I could go off to the side here and I could say, what do I do to get from 1 to 3? I'm zeroing in on those guys. Let's see. What do I have to do to get from 7 to 9? And then just pick another random spot in the table and say, what do I have to do to get from 73 to 75? And this pattern better work all the way through the table. So pick 4 places. You get to pick 4 places where you're going to show some support. So you can either steal mine or you pick your own 4. Again, it's not going to be an equation this time. We're just going to write an algebraic expression having a variable represent the number that is shaded, and how do we get them to the next shaded number. By the way, do we see a pattern going on in that table by just looking at the table? Not a numeric pattern, but can you see a shading problem? A pattern, not problem. Shading pattern. What's going on in that? What's happening in there? Danny? Oh, they're shading all the odds. Okay. What else can you see is going on? Just by looking at it, you're like, oh, this is very clearly happening also. Sylvia?
The shaded are
The shaded are what? Okay, so we have every other column is shaded. Can we say it that way? Every other column is shaded. Cheyenne, do you see another one? columns are increasing by 10. I wonder why they're increasing by 10. Anybody know the reason for that? Why are they increasing by 10, the columns? So in other words, she's talking about you go from 1 to 11, 11 to 21, 21 to 31, it's increasing, you're going, numbers are getting 10 larger. Why is that? What do you think, Danny? Do you think you know? This is a 10 by 10 grid. Oh, so as we're moving across, they're increasing by how much? 10. No. 1, 2, 3, 4, 5. What are they doing? They're individually by box, they're increasing by ones. But then when we look at them as whole rows, it goes from this row starts at 1, that row starts at 11. What's the row increasing by? 10, because there's 10 in the row. What are the columns increasing by? In other words, when we go from as we move across 1 to 2 to 11 to 12, are they increasing by 10s? No, they're increasing by 1s because they're, okay, but when we go and we look at from 1 to 11, we can say there we can see the 10 also. Okay, so there's all kinds of things we should be able to visualize going on there. So now what's the algebraic pattern that's going on? The algebraic pattern, or in other words, what's happening in this table? What do you do to the shaded number to get the next shaded number? Hakia?
Add 2.
You add 2. So I'm going to see if it works with all of mine. 1 plus 2, that's 3. 73 plus 2, yep, that's 75. 7 plus 2, sure thing, that's 9. 97 plus 2, that's 99. Does it work for all of yours? Is that what you got?
Yeah.
Okay, well then what's the algebraic pattern? Write it down. What is the algebraic pattern? What's going on in this? What are you going to write? How are you going to describe that algebraically? And who's got the algebraic description of what we just said? Sylvia?
N plus 2 equals.
Remember I said you don't have to do an equation, so we get to stop at n plus 2. Add 2 to the shaded number, it'll get you the next shaded number. Okay, that's really what's going on in this table. So that's really saying if you add 2 to an odd number, what happens? You get an odd number, don't you? Any odd number plus 2, would that give us another odd number?
Yeah.
That's exactly what this table is showing us. Any odd number, add 2 to it, you'll be at another odd number. Okay, let's look at number 2 then. Write a pattern for the diagonal of shaded squares. See if you can figure out what's going on there. So I want you to come up with 3 examples. So like maybe this one, maybe I'll pick this one, and then I think I'll just be crazy and do an overlap here. Find the side on either side of the table to show some support for what's going on. Okay, numerically, what's the pattern? What's going on? What do you do to the shaded box to get the next shaded one? Cheyenne? You have 11, she says. Do you guys agree with her? Okay, so I'm going to see if it works with the 3 I chose. 3 plus 11, yep, that's 14. 47 plus 11, yes, yeah, that's 58. 58 plus 11, sure enough, that's 69. Okay, so what would that look like algebraically? Sierra?
And plus 11.
N plus 11 would be our algebraic pattern. In other words, the shaded box at 11. Now, before you skip on with that, because I want you to think even harder than that, I want you to tell me, since we're increasing by 11 every time, can you see something else, some other relationship these numbers have to each other? 3, 14, 25, 36, 47, 58, 69, 80. Other than they're increasing by 11. Do you see any other sort of a pattern? Kind of curious. Remember our last one, every shaded number was odd. Is every shaded number odd this time? Well, then maybe everyone is even. No. Think you got it, Danny? Are they prime numbers? 3 is a prime number, isn't it? What does a prime number mean again? The only numbers that go into a prime number are itself and 1. So is 3 prime?
No.
Is there anything else that goes into 3 besides itself and 1? No, so then it's prime. How about 14? Is there anything else that goes into 14 besides itself and 1? Yeah, so it's not prime, is it? So that's not the pattern. They are not all prime numbers. They're not all odd, they're not all even, they're not all prime. I wonder what they are. Okay, I'm going to give you a hint. There's some sort of an alternating pattern going on. Idea? Odd, even, odd, even, odd, even. Tell me something about the multiples of 11. Can we make a list of the multiples of 11? You don't have to do this, I will. What's the first multiple of 11? 11. What's the next one? 22. What's the next one?
36.
What?
33.
The next one?
44.
And the next one?
5.
And the next one?
66.
And the next one?
77.
And I'm running out of room. The next one?
88.
Okay, I'm going to stop for a while here. Tell me something about a pattern going on there. Wait.
It's
Odd, even, odd, even. Oh, that's crazy. I love the crazy things that happen in math. It's amazing. Okay, let's go to one more we have to do, right? Okay, go. Make it happen. I see only 1, 2, 3, 4, 5 shaded numbers this time. 3. I want you to come up with 3 combinations to work with. Okay? What do you have to do to the shaded number to get the next shaded number? No, what are you gonna do? Because these aren't your statements yet, are they? What are you gonna do to make sure? Yes, wait. You think you know what you have to do? Okay, what do you gotta do?
So if you take those numbers and you subtract them, you get 21 each time.
Okay, so every time you did a subtraction problem, you said you get 21. Okay, so what does that mean? What is that? So in other words, the pattern is subtract 21 and you'll get to the next shaded number? So 1 take away 21 is 22. Okay, you have to add. So in other words, when you start with the second number, the 22, to figure out what you have to do, then you do a subtraction problem to figure out how much distance there is between them, don't you? So there's 21 units of distance, so that means I have to do what to 1? I have to add 21 to get my 22, don't I? So that's figuring out how much distance there is between them. And does it work for all 3 that you chose from the table? Okay. So what's our algebraic pattern then?
Plus 20.
N plus 21. N plus 21. Okay. Questions? Are you getting pretty good at seeing these patterns and figuring them out? Yeah? Okay. Let's get out some loose leaf.